Hi, everybody. I don't know how this is going to work out, but I'm hoping that this first take works out all right. I'm going to start by explaining why it is that you hate proofs. And it has to do with the fact that a proof that you see on the right here looks very much like the problem that we see on the left. And I'm going to compare the two. I like to do a side-by-side comparison. And I'm going to start by showing you the 5 problem-solving steps that we use when applying algebra to geometry. Our first step is to have a labeled diagram. And you'll notice I have a labeled diagram there, and I would like to find the measure of angle C. That's what that says. And in order to do that, we start with the labeled diagram, and we're looking at the angles or the angle measurements of a triangle. And so I'm going to use a formula that has to do with the angle measurements of a triangle. And it's called triangle sum. So my first step is diagram. My next step is to write a formula. And the formula is the measure of angle A plus the measure of angle B plus the measure of angle C. And if you add the 3 angles of any triangle, you get 180 degrees. And we call that the triangle sum theorem. Now, I am going to do the next step, which is to substitute. Instead of the measure of angle A, I am going to put 2x plus 4. Now, I like to always substitute inside parentheses. I think that's a really important concept. Plus the measure of angle B. And instead of the measure of angle B, I'm going to put 2x plus 6. And instead of the measure of angle C, I'm going to put 4x plus 10. Sorry, it's looking a little bit jammed in there. Now, the next step is to simplify anything that needs to be simplified. And notice that the 2x and the 2x and the 4x are all on the same side, and that gives us 8x. I have 4 and 6 and 10, which makes 20, and it's equal to 180 degrees. I'm not going to put the degrees until the end. I'm going to go ahead and put it at the end there. Now, I want to solve. I've done a diagram, a formula. I've substituted, I've simplified, and now I have to solve using algebra, and I'm going to subtract 20 from both sides. And I get 8x is equal to 160. And then I'm going to divide by 8. And I get x is equal to 20 degrees. This is the value of my x. But that wasn't what they asked me for. They asked me for what is the measure of angle C. And since I know that the measure of angle C is equal to 4x plus 10, I substitute my value. And 4 times 20 is 80. And angle C is 90 degrees. And we can kind of see it looks like it's a right angle, and it is because we've solved it and we found that C is a right angle. Now here's the problem. A lot of people look at this algebra problem and they think that it is in some way very similar or identical to the problem on the right. And they could not be more different. There is no possible way that they could be more different from one another. And here's the reason. What goes on in your head is exactly the opposite in the two cases. You see, in this one over here, when I started this problem, I did not know what the measure of angle C was. I went and throughout the entire problem, I did not know what the measure of angle C was. And I got to the very last step, and that's when I found out that the angle C was a right angle, and it was 90 degrees. Throughout the entire problem, No idea. I was following the steps. People misunderstand, and they think that when they do a geometry proof, that they're somehow solving it or they're doing something like they've done in algebra. That's not the case. When you do a geometric proof, the entire problem must be done in your head before you write anything down. And here's the difference. In an algebra problem, we start with an unknown value, like the measure of angle C. We go through a whole bunch of steps, and at the end, we get the value out. In a proof, we start with the answer. Before we ever write down the proof, we know that angle C is a right angle, but we can't use that. We have to start with what they tell us. A and B are complements. What does that mean? Well, we know that if A and B are complements, then their sum is 90 degrees. That's something that we know about complementary angles. So angle A plus angle B is 90 degrees. What does that tell us about angle C? Now, because we know that the three angles have to add up to 180, and angle A and angle B add up to 90, then we know that the angle C has to be the rest of that, and that the angle C has to be 90 degrees, which makes it a right angle. All of that is done entirely in your head before you write a single thing on your paper. And you thought that you were going to go through some steps and that you were going to arrive at a conclusion. That is not the case. You must arrive at your conclusion before you start doing anything. Now, in order to get to angle C being a right angle, I can use the fact that the three angles add up to 180, and that if two of them are 90, then the other one is 90. Now, that may seem pretty trivial, but it's extremely important, the difference between those two. So here's my proof. Now, it's going to look a lot like the one on the left here. Here's what I start with. I start with my given. Now, a lot of you know you start with what's given. So angle A and angle B are complementary. And how do we know that? It's given. What does that mean? Well, we know that the meaning of complement means that the measure of angle A plus the measure of angle B is equal to 90 degrees. And that is because that's what we mean when we say complement. When we talk about meaning, we're talking about definition. This is the definition, I'll write it out, of complementary. Now, in order to figure out what the angle C was, we had to realize that we had to add all the angles together and get 180, because that allowed us to realize what's happening with angle C. So the measure of angle A plus the measure of angle B plus the measure of angle C is equal to 180. And I know that because it's the triangle sum, or the triangle sum theorem. Now I'm going to do what's called a substitution, because I want at the end to have the measure of angle C equal to 90 degrees. So I know that A and B add up to 90 degrees. So I'm going to do a substitution. Instead of the measure of angle A plus the measure of angle B, I'm going to put my 90 degrees. And I substituted. I use substitution in order to do that. Now I'm actually going to use the subtraction property of equality. I'm solving an equation by subtracting 90 from both sides. And that is the subtraction property of equality. And when I add those together, I get the measure of angle C is equal to 90 degrees. And all I did was subtract on both sides. I just did um, simplifying, whatever you want to call it. You could write down algebraic steps, or I could write down I simplified or I subtracted from both sides. The last step is to say that the angle C is a right angle by definition of a right angle. When angle C is 90 degrees, then angle C is a right angle. And I know that because that is the definition of a right angle. Like I said, these look very similar. It looks like I did almost the exact same things. And that's why people get confused. I hope you'll stick with me. This may not be as obvious as it sounds at first, but remember, to do a geometric proof, you start with the answer and you have to work it all the way out in your head before you write anything. In algebra, or in an algebraic geometry problem, you start with absolutely unknowns and you work through the problem and end up with an unknown solution. At the very end is when you find out what the answer was. So I hope that helps. I will see you back again sometime, and have a good day. Bye-bye.